My lovely students, welcome to Mathological. Let us start another session on functions and graphs. In this session, we'll be discussing the concept of finding extrema of a function that is defined by maximum or minimum operators. Start karte hain session. And if you've not already subscribed to the channel, make sure to subscribe to the channel as well as press the bell icon. You can also join the Telegram or WhatsApp channel, Mathological, or can message me on Telegram at ADITYAKT. So let us start with the first example. So in today's session, all the functions will be defined by minimum operator or a maximum operator. For example, in this case, our function fx is defined as minimum of 2x plus 1 and 7 minus x. So there will be two cases. Either it will be value of fx will be equal to 2x plus 1 or value of fx will be equal to 7 minus x. Basically, our f of x will be equal to 2x plus 1 when out of the two, 2x plus 1 and 7 minus x, the value of 2x plus 1 will be lesser because fx is defined as minimum of these two values. So when 2x plus 1 is less than 7 minus x, our fx will be equal to 2x plus 1. And in the opposite scenario, when 7 minus x will be less than 2x plus 1, in that case, fx will be equal to 7 minus x. अच्छा, जहाँ पे equality होगा, where both the functions will be equal, both the values will be equal to 2x plus 1 and 7 minus x, we can take either of the values. So कहीं पे भी we can place equality. So this is the proper definition of our function fx. Fx will be equal to 2x plus 1 when 2x plus 1 is the lesser value and equal to 7 minus x, 1 plus 7 minus x is the lesser value. Let us draw the graph first to identify the function, to draw the graph of function properly. So since both are linear functions, 2x plus 1 का graph कैसा बनेगा? For 2x plus 1 at x equal to 0 value will be equal to 1 and slope is equal to 2. And 2x plus 1 will be equal to 0 at x equal to minus half. So this will be the line 2x plus 1. At x equal to 0 y will be equal to 1 and at x equal to minus half y will be equal to 0. Second line equation का ग्राफ कैसा बनेगा? 7 minus x at x equal to 7 it will be 0 and at x equal to 0 it will be equal to 7. The graph will be somewhat like this. So this is 0 comma 7 and this is 7 comma 0. This is our second line and our fx is defined as minimum of these two. So this is their intersection point of the lines. And what will be the value? When these two will be equal, 2x plus 1 and 7 minus x will be equal. 2x plus 1 equal to 7 minus x, solve the equation. So 2x plus x, 3x will be equal to 7 minus 1, which is 6, and hence x equal to 2. At x equal to 2, both of these values, 2x plus 1 as well as 7 minus x will be equal. 2x plus 1 will be equal to 2 into 2 plus 1, which is equal to 5. So at x equal to 2, the value of both the lines, both the functions will be equal to 5. Okay? And for x less than 2, when x is less than 2, in this region, on the left hand side of the intersection point, always you can watch that 7 minus x function is above 2x plus 1. Isn't it so? 7 minus x is always greater than 2x plus 1. So if 7 minus x is always greater than 2x plus 1 and our function is defined as minimum value of these two, so our function will be equal to 2x plus 1. And fx will be equal to 2x plus 1 when x is less than 2. Isn't it so? Similarly, on the right hand side of 2, when x is greater than 2, 2x plus 1 is always greater than 7 minus x. So 7 minus x is the minimum value. So our fx will be equal to 7 minus x when x is greater than 2. And equality पे कहीं पे place कर दो. So let us say we placed equality here. So the desired graph for fx, if we draw that graph in, let us say blue line, blue के बजाय red ही रखते हैं. So with red line, so this will be the graph. Equal to 2x plus 1 when x is less than 2 and equal to 7 minus x when x is greater than 2. So this will be our graph of fx. And question is asking maximum value of the minimum function, maximum value of the function fx that is defined by minimum. So maximum value क्या आएगा? That will be at the intersection point. This is the maximum value, which is equal to 5. Maximum value of the function will be equal to 5 at x equal to 2. The answer will be equal to 5. Okay. क्या ये फंडा clear? If you summarize this thing, देखो, first things first, that our fx is defined as a minimum function of the two given expressions, 2x plus 1 and 7 minus x. Okay. So if we had to find out, let us say, minimum value of the function, so what will be minimum value of the function? So this line is also tending towards minus infinity. This one is also tending towards minus infinity. So minimum value will be in minus infinity, but maximum value has a limit. Isn't it so? So when a function is defined in terms of minimum of two functions or minimum of two values, in that case, minimum value will always be, in most cases, if the function is defined for all real values, minimum value in most cases will be minus infinity. But maximum value will be having a limit, because the function is defined in terms of minimum values. Okay, so maximum value will be having a limit. That is why the question will be asking about maximum value and not the minimum value. So if fx is defined in terms of minimum of 2 or 3 functions, then question will be asking about maximum value of fx. In case otherwise, if fx is defined as maximum value of two given functions, in that case we are identifying maximum value. Okay, so in that case maximum value will not be having any limit. Maximum value might be tending towards plus infinity, but minimum value will be having a limit. The question will be asking about minimum value, because it does not make sense asking about maximum value when maximum value is tending towards infinity. Is that clear? क्या लॉजिक समझ पा रहे हो? ठीक है, so this will be the scenario. अच्छा, also the maximum value will be when the two functions will be intersecting. So we do not have to draw the graph each time. If we find out the intersection point straight away, we'll get the answer, because question asking about maximum value. In case otherwise, if there is a limit to the domain of the function, for example, the domain is not all real values, domain is between two given values, in that case we also have to find out the value of the function at those extreme values. We'll see that example as well. But क्या इतना clear है? क्या अब तक जितना डिस्कस किया, is that part clear? Let us move to the next question. With that knowledge, let us move to the next question. Second question. Now pause the video and try to solve this one. Find the minimum value of the function fx when fx is defined as equal to maximum of x square and x plus 2. What will be minimum value of the function fx equal to x square comma x plus 2? Now again, this time we'll be solving directly by equating these two. Fx is defined as maximum of these two functions, and we need to find out minimum value. Okay, so maximum value will be plus infinity, because fx is defined for all the domain or all real numbers. So maximum value will definitely be plus infinity, but minimum value will be having a limit, and that minimum value will be when these two expressions x square and x plus 2 will be intersecting, yani when these two are equal. X square equal to x plus 2. X square minus x minus 2 is equal to 0. X square minus 2x plus x minus 2 equal to 0. X plus 1 into x minus 2. This is equal to 0. So we are getting two solutions, x equal to minus 1 or x is equal to 2. Either x will be equal to minus 1 or x will be equal to 2. But we need to find the minimum value of the function fx, not value of x. Okay? So ये ध्यान रखना है. So value of fx at x equal to minus 1, that will be equal to, at x equal to minus 1, you can put x equal to minus 1 in either of these two, because the value will be same anyway. So minus 1 plus 2, this will be equal to 1, and 2 square, that is equal to 4. So at minus 1, the value of fx will be 1. At 2, value of x will be 4. And we need to find out minimum value. So minimum of these two is 1. So fx equal to 1, this will be our minimum value. Okay. This is not the maximum value. This 4 is not the maximum value. Maximum value will be plus infinity. But 1 is definitely the minimum value in this case. So answer will be 1 in such a case. Let us make the graph as well. But this much is sufficient to solve this question. Let us draw the graph also. So for x square, graph is very simple. Given function is the x square. So this will be the graph for x square. And for x plus 2, that is also a simple graph, simple line. So at x equal to 0, this will be equal to 2. And slope will be equal to 1. So this will be the graph. This is 2. At x equal to minus 2, this will be 0. So the first solution will be between minus 2 and 0. As evident, we solved at minus 1. And the second solution will be at some positive value. And graph of the function, since function is defined as the maximum value of the given values, so before the first intersection point, x square is greater than x plus 2. So fx will be equal to x square. Between the first and second intersection point, our line x plus 2 is greater than x square. Fx will be equal to x plus 2. And after the second intersection point, again, our fx will be equal to x square only. So this will be our graph. So clearly minimum value is being obtained at this point. This is the minimum value. Of course, this is not the maximum value. Maximum value will be tending towards plus infinity. But minimum value will be definitely at the first intersection point. And to solve that, we need to equate these two, x square and x plus 2. Is this perfectly clear? Okay, let us move to the next question now. Third question, what is the maximum value of the function fx when fx is defined as minimum of 3x square minus 24 and 6 minus x for the domain x greater than or equal to minus 3. So this is the first question where we are putting a limit on the value of x. Now x is not all real values, but x must be greater than or equal to minus 3. This condition is also there. So we have to check two conditions now. Since fx is defined on minimum and we need to find out maximum value, there will be a limit to the maximum value. So maximum value can be obtained by finding the intersection point. Intersection, that is our first step, and the second step will also be checking the value at the extreme values. Since domain is between x greater than or equal to minus 3 and minus 3 and plus infinity, so we have to check the value at minus 3. Okay, we will also have to check the value at minus 3. So first let us solve this. 3x square minus 24, this is equal to 6 minus x. So 3x square plus x minus 30, this is equal to 0. 3 into 30, 90. So 3x square plus 10x minus 9x minus 30, this is equal to 0. X into 3x plus 10, x minus 3 into 3x plus 10 equal to 0. So either x will be equal to 3 or x will be equal to minus 10 by 3. There will be two intersection points. First will be at x equal to 3 and second will be at x equal to minus 10 by 3. But as defined, our function is defined only for x greater than or equal to minus 3. So x will not be taking value minus 10 by 3. That intersection point will not be existing for our given domain. So only concern will be x equal to 3. So this is one point of concern. The second point of concern will be the extreme point, that is x equal to minus 3. So we have to check the value of fx at two values. One is value of x, which is equal to 3, and the second is value of x at the extreme, and that is equal to minus 3. Fx at 3 will be found out by putting value on either of the two, because 3 is one of the intersection points. Okay? So fx ka value at the 3 can be obtained by putting value in any of these two. So 6 minus 3, this will be equal to 3. But at minus 3, you must remember that since minus 3 is not the intersection point, so we have to find out fx ka value. Keep for both these expressions, 3x square minus 24 as well as 6 minus x, and whichever will be minimum, that will be our value of x. So minimum of 3x square minus 24, so 3 into minus 3 whole square, that is 27 minus 24, that is equal to 3, and 6 minus 3, so that is equal to 9. So between 3 and 9, minimum is 3. So this will also give us value of fx equal to 3 at minus 3 as well. So fx ka value is equal to 3 at 3 as well as minus 3. So at both values, fx is equal to 3 only. So maximum value will be equal to nothing else but 3. Option A will be the answer. Okay. Clear? We can again draw the graph. Though drawing the graph is not necessary, we can solve by this much. But if we draw the graph, let us say, so for 3x square minus 24, the graph for 3x square will be same as that of the graph of x square with more steep parabola. But we are also subtracting minus 24, so at x equal to 0, it will be at minus 24. So the graph of 3x square minus 24 will be somewhat like this. And 6 minus x is the straight line. At x equal to 0, this will be equal to 6. And slope is minus 1. So this might be the line. At x equal to 6, this will be equal to 0. Okay. And at x equal to 0, this will be equal to 6. There are two intersection points. And our function is minimum of the given functions. So it will be, before the first intersection point, this will be equal to 6 minus x. Between the two intersection points, this will be equal to x square minus 24. And after the second intersection point, this will be equal to, again, 6 minus x. So our maximum value would have been at this point. But as we have already found out that this value is before minus 3. This is at minus 10 by 3. This is not our concern. And this intersection point is at equal to 3. And then, since our function is defined for x greater than or equal to minus 3, minus 3 will be somewhere before. We are only concerned for values of x after x equal to minus 3 in this range. So this point here will be our concern, and this point here. Either of these two will be maximum value, which in this case, coincidentally, both values are equal. But in case otherwise, we have to check only at these 2 points. Is this much clear? Okay. Next question. Let us solve the next question. Now we have to find out maximum value of f of x equal to minimum of x plus 1, comma 7 minus x, comma x square minus 5. Now there are three expressions, x plus 1, 7 minus x, and x square minus 5, and we need to find out maximum value of the given fx on minimum operator. So fx will be equal to minimum value of these three expressions at one particular x. Okay. So what will be the maximum value of this expression? Now, since instead of 2, we have been given 3 different functions, and minimum of those 3 functions will be value of fx. So what we'll be doing, we have to identify the intersection points or solutions, and we will be equating 2 of these at one time, solving for 2 of these and finding out critical values of x, and then for each of those values of x, we will be finding the value of fx, and accordingly, whichever value of x will be maximum, that will be our answer. Okay, so first of all, let us solve for these two, x plus 1 and 7 minus x. So when x plus 1 and 7 minus x, these two are equal, or the intersection point of these two lines, so 2x will be equal to 6, x will be equal to 3. X equal to 3 will be our solution for these two. Now let us solve for 2 and 3, 7 minus x and x square minus 5. So x square plus x minus 12, this is equal to 0. So x square plus 4x minus 3x minus 12, this is equal to 0. So x minus 3 into x plus 4 is equal to 0. The solution will be x equal to 3 or x equal to minus 4. Now third case, solving for x plus 1 and x square minus 5, intersection point of these two. X plus 1 equal to x square minus 5. X square minus x minus 6 is equal to 0. X square minus 3x plus 2x minus 6 is equal to 0. X plus 2 into x minus 3 is equal to 0. So critical points are x equal to minus 2 and 3. So basically, कितने critical points मिले हमें? X equal to 3 is the critical point for all the pairs. So basically, at x equal to 3, all these 3 functions are intersecting. Isn't it so? But there are other critical points as well. We have to consider those points as well. X equal to 3, minus 4, and minus 2. These are the 3 critical points in our case. X equal to 3, x equal to minus 4, and x equal to minus 2. These are our critical points, and at all these points, we need to find out value of x. So apart from 3, at other points, which are minus 4 and minus 2. At x equal to minus 4, 7 minus x and x square minus 5 are equal, but x plus 1 is not equal to the values of these two. So when we will be finding out value of x, we need to find out minimum value of the given expressions, given 3 functions. So these two will be equal, 7 minus x and x square minus 5 will be equal at x equal to minus 4, but x plus 1 will be having a different value, and value of x will be minimum of the given two values. Okay, so we have to be cautious about that. At x equal to 3, we do not have to worry because all three functions are having the equal value. So x equal to 3 value क्या आएगा? 3 plus 1 4. All will be giving value 4 only. So at x equal to 3, fx will definitely be equal to 4. At x equal to minus 4, 7 minus x will be equal to 7 minus minus 4, यानी कि that is equal to 11. fx will be minimum of 11, which is the value of 7 minus x, as well as x square minus 5, and x plus 1 will be minus 4 plus 1, यानी minus 3. So between 11 and minus 3, minimum value will be minus 3. The value of x will be equal to minus 3. Now the third case, when x is equal to minus 2, at x equal to minus 2, x plus 1 and x square minus 5 are equal. So minus 2 plus 1, यानी कि minus 1 will be value for x plus 1 and x square minus 5. But 7 minus x will be having a different value. So 7 minus minus 2, that will 7 plus 2, which is equal to 9. And minimum of minus 1 and 9 will be equal to minus 1. So there are three values that we are getting, 4, minus 3 and minus 1. I need to find out maximum value, which will be equal to maximum of the given three values, 4, minus 3 and minus 1. So hence maximum value will be at x equal to 3, which is fx equal to 4. So our answer will be fx equal to 4 is the maximum value. Is that clear? Okay. Okay. Now let us do one last question after this. Let us say that we are defining a function. One sec. If h of x is equal to minimum of x and 4 minus x, find minimum value of the function f of x such that f of x is equal to h of x whole squared minus 6 times h of x plus 4. If h of x is equal to minimum of x and 4 minus x, find minimum value of the function fx equal to hx whole squared minus 6 times hx plus 4. Pause the video and try to solve it. Now in this case, hx, which is the input for fx, okay, not as such input, but fx is defined as hx whole squared minus 6 times hx plus 4. And hx is minimum of x and 4 minus x. So what will be minimum value of the function? First of all, let us find out what will be the value of hx as such. What can be the minimum value of the hx and maximum value of the hx? Isn't it so? So first, find out that value. So the graph of x is simple, going through origin. And the second line is 4 minus x. So at x equal to 0, that will be equal to 4. This is our second line. 4, 0 and 0, 4. And this intersection point will be at x equal to 4 minus x. That is at x equal to 2. And at x equal to 2, this will also be equal to 2. This is our intersection point. And hx is minimum of these two. Hx will be basically, when x is less than 2, hx will be equal to the line x. And when x is greater than 2, hx will be equal to the line 4 minus x. So maximum value of hx will be equal to 2. Maximum value of hx is equal to 2. And minimum value will be minus infinity. Hx will be ranging, range of hx is from minus infinity to 2. And hx is basically the input for fx, because fx is defined as hx square, hx whole squared minus 6 times hx plus 4. So we need to find out what will be value of minimum value of the fx, isn't it so? Minimum value of fx, given this condition that hx is between minus infinity and 2. Okay. So if we let us say put hx is equal to some value p, so we can write that fx will be equal to, or f of p will be equal to, let us say, p square minus 6p plus 4. because now this function is looking more simpler. So can you find out कि p square minus 6p plus 4 or fp, at what value this function will be giving us minimum value? Since this is p square minus 6p plus 4, coefficient of p square or coefficient of the term with degree 2, that is equal to 1, that is a positive value. So graph will be upwards parabola, an upwards u, ठीक, upwards parabola, and minimum value will be at x equal to minus b by 2. और in this case p is equal to minus b by 2 है, b is equal to minus 6, तो minus of minus 6 by 2, यानी कि at p is equal to p, we will be getting the minimum value, isn't it so? But p is basically equal to hx only, and hx is only between minus infinity and 2, so it will never be reaching the value equal to 3, isn't it so? It will never be reaching the value equal to 3. क्या ये बात समझ पा रहे हो? क्या ये पार्ट क्लियर है कि एज सच फ्रेश पेज पे करते हैं, लेट अस से fp is equal to p square minus 6p plus 4, where p is equal to hx only, and hx is always between minus infinity and 2. So hx cannot be equal to 3, and the graph for p square minus 6p plus 4, the minimum value will be at p is equal to 3, and that value at p is equal to 3 will be equal to what? This will be 3 square, यानी कि 9 minus 18 minus 9 plus 4, that is equal to minus 5. And at p is equal to 0, this will be equal to plus 4. So this will be our graph, kind of, for fp. Minimum value at p. But the problem is that hx cannot be equal to 3. Hx has to be between minus infinity and 2. So we need to find out value of 2, value at 2. And since hx is always between minus infinity and 2, which is equal to p, so our p will be ranging from minus infinity to 2 only. So we will be restricted to the value of x for this part only. This is the only concern. So whatever value it is taking after 2, that is not our concern, because as x is never going to reach there. Only this part of the graph is our concern, because this is the range of fp. The maximum value will be plus infinity, and minimum value will be at when hx is equal to 2. hx equal to p is equal to 2. So minimum value of fp will be equal to p is equal to 2, यानी कि 2 square minus 6 into 2 plus 4. So 4 plus 4, 8 minus 12, that is equal to minus 4. So minimum value of fx will be equal to minus 4 only. Fx minimum will be equal to minus 4. Is this clear? Okay. So these are all the questions in this session, and I believe whatever we have discussed is absolutely clear. If there is any doubt whatsoever in any question, make sure to comment about that doubt and give a feedback as well about the session. That's all for this session. Bye bye, take care, and keep learning.